Sea salt hides a secret. The tiny drops of seawater that it produces keep geological history. Using specialized equipment obtained from a National Science Foundation grant, Mabrata Weldegabriel, PhD 22, postdoctoral researcher at Princeton University, and Emeritus Professor of Earth Sciences of the Hart Lowenstein, of Binghamton University, was able to piece together changes in seawater chemistry over the past 150 million years, also gaining insight into the geological processes and associated climate change. Their paper, Undersea Hydrothermal Systems Control Long-Term Changes in Seawater, Li+, Evidence from Fluid Inclusion, was recently published in the journal Science Advances. Lowenstein explains, the ocean is like a giant soup of many different elements. Sodium and chloride are the most common, but there are dozens of others dissolved in seawater in trace amounts, such as lithium. They examined sea salt, halite, that was formed at different times over the past 150 million years in geographically diverse sedimentary basins in the United States, Europe, Asia, and Africa. In the salt samples were small pockets of ancient seawater. To reach the droplets, the researchers used a laser to drill holes in the salt crystal, then used a mass spectrometer to analyze the various trace elements present. In this study, they specifically focused on the concentration of lithium, a trace element that has decreased sevenfold over the past 150 million years, along with an increase in the ratio of magnesium to calcium. But why? The causes of long-term changes in seawater composition have been debated over the past 2 decades. The researchers suggest that the decline in lithium concentrations in seawater is mainly related to reduced oceanic crust production and reduced seafloor hydrothermal activity, both of which are influenced by tectonic plate movements. Create. The slowdown in plate activity over the past 150 million years has resulted in the addition of less lithium to the ocean and a reduction in the amount of carbon dioxide released into the atmosphere, ultimately leading to global cooling and the current ice age. Going back 150 million years ago, Earth was a warmer place with more carbon dioxide in the atmosphere and more lithium in the sea. There is a strong connection between ocean chemistry and atmospheric chemistry, Weldegabriel said. Whatever changes are happening in the ocean, they reflect what's happening in the atmosphere. The oceans and atmosphere are interconnected, and the way they change is also linked, Lowenstein explains. Everything is connected.